All right, so this session is going to start with 5.6, solving equations containing decimals. So we'll be solving equations in the same fashion that we would if there were no decimals. As a simple example, if I have x plus 3.7 equal to 5.42, and I wanted to solve for x, then I would subtract 3.7 from both sides. .7 will cancel on the left. X is equal to 1.72. All right. All right, so if I have 2.4x minus 3.85 equal to 8.63, I would look to move the 3.85 first. So I will add 3.85 to both sides, so that 3.85 will cancel on the left, leaving me with just 2.4x. And on the right, we'll have 12.48. Now we have 2.4x equal to 12.48. So to move the 2.4 off of x, since that's 2.4 times x, I need to divide both sides by 2.4. X is equal to 5.2. And so like I mentioned before, you're solving these the same way we solve the regular equations. It's just that these have decimals involved. All right, so we have 0.03 times x plus 4, so we want to distribute at 0.03. 0.03x, 0.12, 0.0x was 2.8. So now we recognize that we have our x variable in more than one place. So your goal should be to get all of your terms with x on one side, all of your terms without x to the other. So I will subtract 0.01 x from both sides. They cancel on the right. On the left, we have 0.02x plus 0.12 equal to 2.8. Next, we'll subtract 0.12 from both sides. The 0.12 will cancel, leaving you 0.02x on the left. And on the right, 2.68. Now we can finish it off by dividing both sides by 0.02. We cancel on the left. On the right, we got 1, 3, 4. All right. Questions. See, I saw one example like this. All right, so the sum of a number and 7.5 is 3 times the number. So if they want you to solve something like this, have an algebraic expression for you to convert, one of the keywords you could look for is the word is. That's your equal sign. So we can start off with the sum of a number and 7.5. Sum represents addition. So the sum of a number and 7.5 would be x plus 7.5. And like I said, is your equal sign. And then 3 times the number is just 3x. All right, questions on the setup. All right. So now we want to get all of our x terms to one side. So now we can subtract x from both sides. So they cancel out on the left, leaving me with 7.5 equal to 2x. Now divide by divide by 2, because that's attached to the x. 2's cancel. That's 3.75. All right, questions on anything in that section? All right, so next we have ratios and proportions. So I'll do both of those and then we can call it a day. All right, so your ratios is a comparison of two quantities. Can be written one of three ways: A to B, A colon B, which still represents 2 word-wise, and then A over B, once again, represents 2, but it's written as a fraction. All right. They start off in class, there are 15 women and 17 men, and they ask us to write the ratio of women to men. So all that is just 15 over 17. The ratio of men to women, 17 over 15. Then they want us to write the ratio of women to the total number of people in the class. So the total number of people in the class is 15 plus 17, just adding up both categories, men and women. That's 32. So the ratio of women, which is 15 to the total number of people in the class, 15 to 32. All right, any questions on that? All right, write each ratio in lowest terms. Okay, so we're going to write each ratio in lowest terms. First one, 15 feet to 10 feet. So it's just 15 feet over 10 feet. Then you reduce them accordingly. The feet measurements will cancel out. Don't hold on to those. And then 15 is 5 times 3. 10 is 5 times 2. 5's cancel. And that'll be a 3 to 2 ratio. All right. So the $20 to $10. 20 to 10 ratio. So the 10's cancel, leaving you with 1 in the denominator. So that's a 2 to 1 ratio. So since we're dealing with ratios, you would just keep that as a fraction. Let's do this one. So if I have 7.5 to 6.25, right, that's 7.5 over 6.25. Now I want to get rid of these decimals. And because my largest decimal place is to the hundredths place, I'm going to multiply top and bottom by 100 to get rid of that decimal. So that would be 750 over 625. All right. So now I look to reduce this. That's 750 can be broken up into 75 times 10. I'm just breaking it down this way just to make sure everybody see what's going on. 75 is 3 times 25. 10 is 2 times 5. And then that's 25 is 5 times 5. So let me see. I'll do this first. Let me break down 625. That's 25 times 25. And if you didn't know, the numbers that I'm using, always start with what you do know. Just like 750, it ends in 0, so you could divide that by 10, or it ends in 0, so you can divide it by 5. 625 ends in 5, so you can divide that by 5. So you start with the values that you know, and then you look to break it down from there. So we're looking at 2, 2, 3, 5, 5. Is that 3 5s? 3, yeah. And then 4 5s. So 3 of the 5s will cancel. 2 times 2, well, I'll just write it like this. That'll be 12 over 5, or 12 to 5 ratio. Do I have extra 2? You know what? That I got an extra 2 in there. Sorry, I saw this 2 over here and included. That should be just 1 2. Should be 2 times 3. Yeah, it should be 6 over 5. I threw an extra 2 in there by mistake. All right, questions before we do one more. All right, so we have 2 and 1/4 plus 3.5. And we're going to set it up as a ratio. We'll set it up this way. And so since we have this situation, we should go ahead and convert to an improper fraction. I don't know why I'm going that way. So that's 2 times 4 plus 1 over 4 for the first one. So 2 times 4 is 8 plus 1 is 9/4. And then for 3.5, that's 3 times 2 plus 1. And 3 times 2 is 6 plus 1 is 7 over 2. So now I have 9 over 4 divided by 7 over 2. Any questions so far? All right, so this is 9 over 4 divided by 7 over 2. All right, that division bar is the same thing as this divisional sign. Don't forget, when you divide by a fraction, you multiply by the reciprocal. So that's 9/4 divided by 7 over 2. That means we have 9/4 times 2 over 7. This 2 can cancel out with the 2 that's in the 4. And now if I multiply across, that's 9 over 14. All right. Questions on any of those before we take this and use in our proportions? So a proportion is just a statement that two ratios are equal. Example of that is 2/3 equal to 12/18. All right, so first exercise I see here is to write a proportion for each statement. And so the first one, 5 is to 12, as 30 is to 72. So you just write 5 over 12 equal to 30 over 72. All right, so the numbers -3 and 7 are proportional to the numbers -12 and 28, excuse me. So just -3 over 7 equal to -12 over 28. All right. Any problems? All right, so your cross product relationship, if A over B is equal to C over D, that means A times D is equal to B times C. So we will be able to take our denominators up to multiply to the opposite numerators. If that actually is a proportion, once we do our multiplication, the result should be the same on each side of the equation. So if I go back to 2 over 3 equal to 12 over 18 and apply the cross product, and you always take your denominators up to the opposite numerator. On the left, I will have 2 times 18. On the right, 3 times 12. And that would be 36 equal to 36, which lets me know I do have a proportion. All right, so we want to determine the ratios form a proportion. So what we would do is cross multiply. On the left, 3 times 15. On the right, 5 times 9. So 3 times 15 is 45. 5 times 9 is also 45. Since they equal, the answer is yes, it forms a proportion. All right. The next one, 8 over 4 and 10 over 5 halves. So we do the same thing. All right, so we have 8 times 5 and a half, 4 times 10. 4 times 10 is going to be 40. Now 8 times 5 and a half, that 5 and a half, we return it to an improper fraction. So that's 11 over 2 times 8. We're going to just multiply across. 88 divided by 2, and that is 44. So we have 44, and we're comparing it to 40, and that is not equal. So no, it does not form a proportion. All right, so before we look at the last type of problem that you may see, does anyone have any questions on anything? All right, so last thing we'll see in this section is to solve. We're going to have proportions that are missing one piece, and we can solve for the missing piece by cross multiplying. So if I have x over 13 equal to 6 over 39, cross multiply. On the left, we have x times 39. Now we know these are equal. They're not asking us if these are equal, they're asking us to solve. So we want to know what's the piece that will fit in for x that will make the proportions equal or make the ratios equal. So once again, cross multiplying x times 39, 13 times 6. So on the left, 39x. On the right, 13 times 6 is 78. Divide by 39. 39's cancel on the left. X is equal to 2. All right, so 4/15 equal to 9 over n. Cross multiply. It's 4n. 15 times 9 is 135. Divide by 4. N is equal to 135 or 33, I think, 0.75. Let me see. Yep. So Connect Math will let you know which answer they want or what form of answer you want, but either one of them should be fine. Okay, let's do at least one more. All right. So once again, we're going to cross multiply. We have negative 12 over negative 8 equal to x over 2/3. Negative 12 times 2/3, negative 8 times x. If you want to multiply these across, you could. That would be a negative 24 over 3, or you could have took 3 to the 12. Cancel out from there. Negative 24 divided by 3 is negative 8. Divide both sides by negative 8. So we can cancel out that negative 8 that's on x. On the left, negative 8 divided by negative 8 is positive 1. So x is equal to 1. All right. Questions? Any questions, concerns, comments? Is everybody good? Everybody straight? All right. So we could keep going, but I think we got plenty of time. Yeah. But that's 3 sections right there. That's good for today, especially considering that some people are going to have to go back and review this video. So, any questions before we close out? Everybody clear and okay with what's going on? All right. So if you guys are good, I'm good. Don't forget to, if any questions come up while you away from class, feel free to email me. And outside of that, I will see you guys on Thursday. You guys have a good one. All right. You the same.